Hey guys, welcome back to my YouTube channel. So in this video, I'll be doing another example of a Markov and Chebyshev inequality and the weak law of large numbers problem in probability. State and prove the weak law of large numbers. This is an example of a weak law of large numbers problem in probability. So let me write it down. So let x1 all the way to some n, xn be a sequence of independent and identically distributed random variables, each having a finite mean, or in other words, that's just the expectation, e to the xi is equal to mu. Then, for all epsilon greater than 0, the probability that x1 all the way to xn over n minus mu, or in other words, so taking the distance, is greater than or equal to epsilon, which approaches 0 as n goes to infinity. Now we're going to prove this. Let me write down a proof here. And we can assume that the random variables have a finite variance. So first, let me write down this would be equal to e to the x1 all the way to e to the xn. This is bilinearly of expectation. And we could see that this is the same as just 1 over n times n mu. And we can see that the mu's cancel, and we get mu. And let's do, for variance bilinearly of expectation, and this would be n variance bilinearly of variance. And we could see that the variance is equal to 1 over n squared times n mu squared is equal to variance over n. And this applies from Chebyshev inequality. And we could see that the probability x1 all the way to xn over n minus mu is greater than or equal to epsilon, which is also less than the variance over n epsilon squared. So this is how we proved it. Weak of law, large numbers. And the variance in epsilon squared is a constant. So this is another example of a Markov and Chebyshev inequality and the weak of large numbers in probability.